Hi, welcome back to the Biddle stage. I would like to present Sam Green, founder of Cambrian.
Hi, everyone. For today's talk, I'm going to introduce myself, and then I'm going to talk about reinforcement learning and the types of problems that it solves. I'll then talk about reinforcement learning applications in DeFi, and I will give some tips on getting RL working if you're a builder, and then I'll give a quick introduction to Cambrian Network, which is my current focus. For some context setting, this is a research-oriented talk, and I'm trying to distill a lot of the knowledge that I've gained over the years on this topic for builders in this talk. So I started my career hacking cryptography hardware. I did that for 5 years, and then I went and worked on a PhD in reinforcement learning, specifically high-speed RL or low-power RL at UC Santa Barbara. I finished that in 2019. And then I co-founded Semiotic Labs. Semiotic Labs is a core dev team in the graph. They are focused on AI and verifiability for the graph. Semiotic also is the parent company of Odos, which is a leading DEX aggregator. And Semiotic is also the parent company of my new project. And also, if you're taking pictures, I have a QR code at the end of the deck, and you can get all the slides if you'd prefer to do that. So, reinforcement learning is a branch of AI that is focused on learning through trial and error. The inspiration for RL comes from behavioral psychology, and basically it's the way that all animals, including humans, learn everything. And so what we've done in RL, the computer science implementation of RL, is take models of animal learning and implement it in algorithms. And with RL, you can use RL in basically two environments: simulation, where your agent can learn things in simulation, and then you can map that simulation or what you learned in simulation to the real world, or you can actually learn online in the real world, or your agent can. Whenever you start getting into RL, you'll see a diagram like this, where basically what's happening is you have an agent, in this case this little robot spider, that is making actions based on what we call a policy. So a policy just means a decision-making function. So an agent has a policy. You can think of it as its brain, and that policy is what determines what actions the agent is going to take in its environment. And most importantly, the environment will also output rewards. And the goal of the agent is to learn to take actions that can maximize its collection of rewards. This is a recent example of using RL to train this robot that's riding a bicycle. This came out about 2 weeks ago. The policy for this robot was trained in simulation using reinforcement learning, and then after it learned how to perform these tricks in simulation, they just copied the neural network or the policy that was learned into the actual physical robot. And the interesting thing about RL is that it can learn behaviors that are at expert human level or beyond human level. That's the reason that reinforcement learning is really exciting. When I think about what reinforcement learning is doing at technical level, I think about things in terms of trajectories. If you think of what's happening for decision-making tasks, you often have to do many different things over a long time horizon to get to a goal. For example, let's say where you are in life right now is the result of many decisions, some good and some bad. And the idea with reinforcement learning is to basically pick decisions over a long time horizon that can lead to an optimal outcome. And maybe for some intuition, if you think about what's happening with an LLM as it's generating its words, there are many directions that an LLM can go. There are many different types of sentences you've seen or code that you've seen an LLM generate. And you can think of those as trajectories. Each token that the LLM outputs, you could think of it as a decision working towards some sort of long-term goal. And in general, RL is used to try to find the best sequences of actions to get to the best long-term result. And you could think of what's happening in finance. It's not just a single decision that you're making in any sort of financial transaction. Really, you're working towards some long-term goal. Even if you buy an asset, eventually you have to sell it. And so it's a sequence of actions, even just with a simple transaction. It's not just one thing. And of course, with finance, you're looking at maximizing long-term gains, which often could involve hundreds or thousands of actions over many, many years. One more RL example, and this goes back to the fact that RL can lead to things beyond imitation learning. DeepSeek was the first public use of reinforcement learning for training a LLM. Whenever LLMs were initially created, they were just trained to mimic everything that people said on the internet. But what happened during the training of DeepSeek, and this is actually a screenshot from the DeepSeek paper, is that midway through training with reinforcement learning, the agent actually learned to identify the errors that it was making in its thinking, and then readjust itself on the fly during training. And if you think about what you would find out on the internet, you don't really see people thinking through their thoughts, correcting themselves, and then continuing. Because normally what people post is their finished, edited product. And so you're seeing this sort of emergent behavior that happened because of RL. Well, like I said, finance is inherently a sequence of making, a sequence of decisions that are made. In finance, you have this exploitation problem. And in general, RL is really good at optimizing problems where you have to make a decision, or where your agent has to make a decision between exploring and exploiting. And so in finance, an example of exploitation would be saying that you know treasury bills offer a certain amount of yield. So you could exploit that fact to get that little guaranteed amount of yield over some time horizon. Whereas exploration might be saying, well, I know there are other assets that might have higher volatility, but they could have higher yield. So maybe an agent could decide, instead of just exploiting this low guaranteed yield option, it could go and explore and try to find other types of yield. Also, RL is good for working under shifting dynamics. As you know, regulations are changing, new tokens are popping up or disappearing, companies are doing better or doing worse. In finance, you wouldn't just use some fixed strategy usually. You would want your strategy to adapt over time. So for the next few minutes, I'm going to go into some examples of where RL is being applied in finance applications. And I'm just going to use 3 example classes of problems where people, especially academics, have been talking about using RL. One is for algorithmic trading bots. The other one is for robo-advisors and automated portfolio management. And the third class that I'll talk about is agent-based modeling. But before I go into those example domains, I'd just like to talk about who's using RL in finance today. Well, at a high level, financial institutions aren't eager to share the details of their strategies, because when they share those details, they're basically giving away alpha. They're giving away their gains. The more people that are using a strategy, the less valuable the strategy is. But we can assume that at least hedge funds have at least experimented with these techniques. These guys are hiring lots of computer scientists and mathematicians who understand these techniques really well. And we know that, but hedge funds aren't really they're not going to talk about this stuff. Banks and asset managers are publicly exploring RL, and they're publishing about it, and they're talking about their results. They're not really trying to protect alpha. They're trying to do things like get better orders executed and manage their risk. So they don't really mind sharing the details as much, because oftentimes these sorts of institutions are public about their strategy anyways. And then I've been talking to some crypto projects that are starting to use RL for DeFi. Well, let's look at some examples of the algorithmic and high-frequency trading problem space. These are general problems that exist today. People have solutions for this today, but RL is an interesting approach to consider for these problem domains. We'll start by looking at market making. A market maker basically buys assets at a slightly lower price than the current spot price, and they sell those assets at just a little bit above the spot price. And they make a profit on what's called the bid-ask spread. And it is risky for them to hold these assets as the spot price is shifting around. And so they have to decide when to buy, when to sell, how much to buy, how much to sell, and at what prices. This maps nicely to RL, because they're not just looking for a single successful buy-sell decision. They're trying to maximize their profits while engaging in these pools over a long time horizon. Also, arbitrage bots. Arbitrage bots are looking for assets that can be purchased cheaper in some market and sold at a profit in a higher market. And there's execution risk, and there is competition for doing arbitrage because it's free profit, and it's something that you would want to be automated. The second class of problems is liquidity provision and yield farming. You could use RL to build automated liquidity providers. This maps to DEX DEXs. With DEXs like Uniswap, you basically have liquidity providers that put in pairs of assets, let's say ETH and some other token. And the risk here is that when one of the tokens is pumping with respect to the other token, and everybody's buying the token that's pumping, and it leaves the liquidity providers with the less valuable token. But liquidity providers also get trading fees for providing liquidity. And so there's this complex decision process on how much liquidity to provide, what assets to provide it in, when to remove the liquidity, which will be based on the market and your belief about how the market's going to move. And this is, so RL could be used here. People are starting to apply RL in DeFi, but it's very early, and I think there are a lot of opportunities for builders with a financial background to start experimenting. Now I'm going to go over some challenges with RL. We have, especially in finance and DeFi, we have behavior, sentiment, and lots of risk that's constantly shifting around. An agent needs to be able to deal with all of these changing conditions. You also have delayed rewards. The longer your reward is away in time, the more difficult it is to train an agent or a policy that can go after that reward that's potentially way out in time. We have, a lot of times, these live markets are difficult to simulate, and so it can be hard to actually capture the real world in a simulated environment. Your agent might have to actually learn in the real world, which in a financial setting could have a lot of risk. It's also difficult to answer what-if scenarios with RL. For example, let's say you're dealing with some low market cap pool, then if your agent did something, it could be difficult to test in simulation how the actual market would respond in reality. These sort of what-if questions can be hard to test. Also, explainability is challenging with RL. Especially with neural networks, it can be difficult to tell what a neural network is doing and why it did something. And this, by the way, is probably one of the reasons that RL hasn't been widely adopted in finance, is because of explainability. And finally, we have regulatory risk for active management of users' funds. Some tips for solving problems with RL. If you have human training examples, you should use that. You should start with supervised learning to get your hands on the data and get experience with the data. You should try classical approaches first to become familiar with how you would solve the problem generally. And then I recommend checking out some classic RL algorithms and getting experience with that. Then you can approach the RL solution. Finally, Cambrian Network is providing high-speed financial data to DeFi agents. If you're building anything agentic with finance, I'd love to talk with you. Thank you.